is the Chapter 3 test. And from what it looks like, the test itself is about 16 or so, 17 questions or so. But it's all basic. It's all basic, the same stuff that we've been working on. There's nothing that I have on that test that we haven't seen and or done numerous problems of at all. There should come nothing on there should come to you as any surprise as far as how anything is written. What I try to do is always write out, how you solve the problems, how you have the explanations of the problems and whatnot. Yes, sir. And you put it back when you're done. The things like that, where the instructions are very similar to everything you've seen in homework. So that way, it doesn't skew off of that. See that? So 3-1 things. It had a bunch of definitions. Speaking of, it had the word skew in it. We had skew, we had parallel, we had planes, we had transversals, we had all those kind of big terms there. 3-1 was the basic, kind of like reintroducing you guys to all the different types of angles that can occur when two lines intersect, when two lines intersect with the transversal. All of those things came back, but we didn't really work so much with those angles until you got to the point where you were knowing that things were parallel. So in 3-2 and 3-3, those were your angle pairs stuff. When you had two parallel lines cut by a transversal. And when we did those, it was a matter of, well, are we looking at specific types of angles? Are we trying to name the angle pair relationship? Are we trying to solve for x, find an angle, or whatnot? So the main ones that we talked about were corresponding, alternate interior, alternate exterior, and then what we called consecutive interior. The book called it a little bit different. Yeah, same side interior, same side inside. Okay. So when we're looking at these things, it was just a matter of identifying where they went, how they matched them, and how they looked against set diagrams. One of the things that we did with these 4 types of angle pairs, I thought the easiest thing was if you had parallel lines in the transversal, it didn't so much matter that you knew exactly which set of these things they were, because we knew that if you had corresponding angles, they were congruent if they were parallel. These were congruent if they were parallel. These were congruent if they were parallel. And these were supplementary if they were parallel. Whereas, what? Did you guys put that? I won't be there though. Thanks. Hey, good luck. So what we did a lot of times in class was just this. Remember, we just picked a spot, vertical, alternate interior, and vertical. So if they matched up, they were congruent. If they matched up not sharing a tick mark, they were congruent. If they had one of each, they were always what? Supplementary. Very good, very good. Yes. Too late. Softball tosses, man. Those too easy, right? So what would happen a lot of times with these things, it wasn't just a matter of quick numbers and whatnot. It was, in fact, did you have to solve for x to figure out certain parts? For example, we had problems at some point somewhere around here that looked like this. Where you had to be able to solve for x and y. So take a minute and solve for x and y. So if I go back and look at it, what do those two have to add up to equal? They do. I would hope so. Now, what? It's fine. Put it back on the fish. Anyway, so one of the things you can do.
It's in there now. I can't get it. I'm really trying.
If there was only a mechanism by which you could use chopsticks close to you. Oh. Wipe that in his face. Now, yeah, I know she's holding on too. One of the two things you can do, you can add 4y negative 16, 68 and set it equal to 180, or what's the supplement to 68? 112. You can set this equal to 112 right away. It's a little bit quicker to do it that way. It works the same way. Add the 16. You're gonna get 128 for y. You still get 32. Okay. Yes, I have. I had it posted, but I have the actual review sheets themselves. So I was having you guys work on this. You guys can have on this class, but you're available. You do the same thing down here. Now, when you're working down here, you have to figure out what to set it equal to, which means I have to set it equal to, again, that 112. Okay. That's just a shortcut way of doing it. Be careful. Use those tick marks. Use that tick mark trick. Okay. Add your 24. You get 2x is 136, I believe. X is then 68. Okay. Shouldn't be so bad. Now, not only do we use parallel lines transversals to figure out what x's and y's were, sometimes you also had to figure out what was the value of x that made something parallel. For example, if I had something like this that didn't show up, a second and see if you figure those out. Just two different types of problems there. So you start working with the 1. Sum of the exterior is equal, or sorry, the exterior is equal to the sum of the 2 it doesn't touch on the inside. So that means that we have 4x plus 8 has to equal 2x plus 54. I just put it together right away. Subtract the 2x, subtract the 8, we get 2x 46, and then x is 23. You okay on that? Now, the one on the other side there, you got to pick a place to start. What's that little box needed in the lower right-hand corner? 90. Okay, good. So that means right off the bat, that leaves you 90, 39, and something for angle y. Well, the something's pretty easy to find. 51. Okay. How many degrees are in a triangle? Take out 90. How many are left? Okay. So 50 and 51 is 101. That leaves you 79 for here. Which means 56 and 79, add those two together, subtract it from 180. So that gives you what? 135? And then leaves you the answer. Very good. Nice work. Yes, you are correct. Again, it's a matter of picking a place to go and work your way out. You pick a spot, and in this case, that was the easiest spot to start. Enough, please. Now, after we did all those types of problems, we switched back into the old-fashioned slopes, slope-intercept, point slope, parallels, perpendiculars, all that kind of fun stuff. We also did graphing. Now, one of the things that we did, which we've been working on, I don't know, for the past 4 days, really, is that you've had slopes, change in y, change in x, slope-intercept form. This was the easy way to graph. Point slope form. Guys, there's way too much going on. You had point slope form, and you did that all the time when you had 2 points, find the slope, substitute in, solve for y. We used point slope all the time also when we were working with parallel lines, perpendicular lines, because you had to write the equation, which means you had to identify slopes and go through all the process as well. Now, none of that changed over the course of the past, well, basically 4 days, because back on last, what would have been, Wednesday, last Wednesday we started this, or Tuesday or Wednesday, one of those 2 days, and then Thursday, Friday, and then yesterday we continued it. So we had a good solid 4 or 5 days of basically the exact same thing. Now, what happens here is that you have to make sure that when you're writing things out, you understand what you're looking at. For example, if I want to write the equation of a line, this was to get it into what format? Slope-intercept. Slope-intercept form says y equals mx plus b, which means what variable do you have to get by itself? Y. Okay. In this case here, I have. Let me rewrite it. Let's say I have negative 5y equals 7x minus 15. We'll make it look a little more user-friendly. What do you do to get y by itself? Divide by negative 5. What am I divided by negative 5? Everything. Good. Negative 15 divided by negative 5? Go from there. Okay. Now, if I go to graph that, where do you start it? The y-intercept is pretty good. My y-intercept is 3. Is that the up and down, or is that the left and right? Down. Good. My slope is negative 7 over 5. What direction do we go first? Down 7, right 5. Good. 3 little spots, 4 little, 5 little, 6 little spots, 7. 1 little, 2 little, 3 little spots, 4 little, 5 little. And unfortunately, we don't have enough space on this graph to continue to walk that. Whereas if we did, we could just walk yeah, I could have gone up here. It would have been 3, it would have been over here at 10. That's pretty close. Not too shabby, not on there. You get stuff like that. When you're graphing, that's what you want to do, guys. You want to get y all by its lonesome. And go off of that. What I have for you guys tonight is I do have basically works out like 2 or 3 problems per style problem on this entire time. There's really no hidden stuff that we have done. It's all extremely straightforward. Yeah. I don't mean to get the plot right and drive my paper cuts. These are all review stuff. I will collect this tomorrow. Guys, there are good examples of every style problem that we have done. Nothing here will come to any surprise whatsoever. Yeah, it's just all review. I know it seems like a lot, but a lot of this you'd be able to fly right through because, well, this is kind of forces you to study for your test. Okay. You guys have time now to work on it? Well, let's introduce you while you're doing so. That's fine. We're trying to keep it to the level form. Ladies and gentlemen, there are many a problem to do. Sir.